Today we will discuss damped electrical oscillator. So it is same as the damped mechanical oscillator which we have already studied. In this oscillator we will use three components, that is L, C and R. L means inductor, C means capacitor and R means resistor. So this oscillator consists of LCR circuit. So basically it is LCR circuit which you have already studied in 10+2 class, that is inductor, capacitor and resistor. So this is circuit diagram. L and C both are parallel and resistance R is connected in series with L. So this is called LCR circuit. So this circuit is consisting of three parts, three components, three elements L, C and R, and we know the functioning of each element very well. You know that the voltage across inductor, voltage across resistor and voltage across capacitor. So voltage across inductor is minus L di upon dt. You have already studied, that is by using Faraday laws. And VR, voltage across resistor, is IR. It is from Ohm's law, V is equal to IR. And VC, voltage across capacitor, is Q by C. So there are three types of voltages: voltage across this L, across R and across C. Now the equation for this oscillator is formed by using Kirchhoff law. So by using Kirchhoff's law, so you have already studied Kirchhoff's second law, that is law of voltage. So in this case, the voltage across inductor VL is equal to voltage across resistor plus voltage across capacitor. So you may put the values of these voltages: VL, that is minus L di upon dt, and VR is IR, and VC is Q by C. Or we will convert this equation in Q terms, that is Q variable charge, and we will change this current in terms of Q. So since I is equal to dq by dt, you know that the rate of change of charge is called current. Therefore the equation become minus L into d dt of I means dq by dt, so it will become d square q upon dt square. Sorry, is it clear? Is equal to I means dq by dt, so R into dq by dt plus q by C. So this is the total equation in terms of Q and T, charge and time. Now we may write this equation as L, that is d square upon dt square, it is plus R dq by dt plus q by C is 0. We have done this term, we shift to right hand side and left hand side becomes 0, and overall we will get this equation. So this is the equation which is quadratic in Q, or dividing both sides by L, that is d square q upon dt square plus R by L dq by dt, this one, plus q by LC is 0. 0 upon L means 0. So to make the coefficient of this second order term should be 1. This coefficient should be 1. Therefore I have divided both sides by L. Now put these constants as 2b and omega square. So put R by L is equal to 2b and 1 by LC, this is LC in the denominator, or 1 by LC, it is omega square. So we will get this equation will reduce to d square q upon dt square plus 2b into dq by dt plus omega square q is equal to 0. So this is standard equation for damped oscillator, which we have already studied this type of equation in mechanical oscillator, but the difference is only that in that equation there is x instead of q. So here in this equation it is q and t. So it is, this equation is same as that of mechanical oscillator, just with the replacement of x with q. So if the equation is same as mechanical oscillator, therefore the solution of this equation is also same as mechanical oscillator. So we will consider the solution for this equation, that is q is equal to any constant into e power alpha t and so on. We will follow the same steps as we have followed in the mechanical oscillator. So you will get the same type of answers, that is you can solve yourself this article and you will find overall the resultant equation is e raised to power minus bt into e raised to power b square minus omega square into t plus e raised to power minus under root b square minus omega square into t. So this type of equation will be obtained on solving this equation and by following the same steps as we have followed in the mechanical oscillator. And the result is also same. Only difference is here it is q, but in that case it was x, and therefore the same three cases arise, that is heavily damped, critical damped and lightly damped. So in this case again three special cases will arise. First one is heavily damping, that is b square is greater than omega square. This factor will decide the case, special case. If it is positive, it is called heavily damped. If it is 0, then critically damped, critical damping, then b square is equal to 0 or b square approximately equal to omega square, because we have studied that b square can never be equal to, it is very approximately equal to omega square, very close to omega square. And third case, lightly damping, that is b square is less than omega square, then this term will become negative and square root of negative term is iota, and in the third case it is harmonic decay. So you have already observed that these three types of graph, that is this one and first one is heavily damping and third one is critical damping. So critical, having and heavily and lightly damping cases. So these cases will be, the graph shows the variation between q and t. So same type of results we will obtain in this article, but only difference is x is replaced with q and the frequency omega square is 1 by LC and b square is 2b is equal to r by L. So this is damped electrical oscillator. And in our next lecture, we will discuss different damping factors, or which factors are responsible for damping. Thank you very much.